Hello, everybody. Welcome back. We got another lecture, right? We're gearing toward the end of this semester, and just I believe one more chapter here to go. And what I will say is that this chapter seems a little bit smoother than the last one. Chapter 9 was the big chapter. That was the tough one. So hopefully this feels a little bit smoother. But let's talk about it. Law of sines. So here's the thing. Let's start with an example. Oops, sorry, pen has frozen. Okay, there we go. Start with an example. And if I said solve the triangle, right? We've solved tons of triangles before. Solve the triangle. And it looked like this. And I said this is 15 degrees, this is 35 degrees, and maybe I called this an A, a B, and a C, and I knew A was equal to 20. And you'd look at this, and hopefully you'd say, I can't do this. Because off the bat, I know that this angle must be, if that's 15 and 35, it's got to be 130 degrees. So it's not a right triangle. We've never dealt with a triangle like this. So some of us who kind of see the pattern might notice what I can do is make two right triangles and then solve for there. So we can write that. We can make two right triangles. And solve. And of course, we can do that. We can spend some time and do this, and this is within our abilities, and that's great. But if we can do this, what we hope is that there's a system of doing this over and over and over again, which hopefully gets us a more efficient way to solve just one triangle instead of two right triangles. And it turns out there is. It's called the law of sines. So what I'll say is, before we write any facts, I'll say recall 4 types of triangles. And perhaps we remember this from our high school geometry class. We know that there is an side-side angle. There's a side angle side, a side side side, and then there is a angle side angle. All 4 of these. And none of those are guaranteed to be right triangles. They could be, but with these pieces of information, I can solve any triangle now. It turns out that these two are the law of sines, which we're going to learn first, and later in today's lecture, we are going to do law of cosines, which will be those two. So let's talk about it. What is this law of sines that I keep talking about? Law of sines. So for a given triangle, for any given triangle, it would have to look like this, where little a is across from the angle A, little c is across from the angle C, and little b is across from the angle B. This holds true. Sine of big A over little a equals sine of big B over little b equals sine of big C over little c. And what's also true is, and this is true for any equation, if you have two fractions that equal each other, you can always flip them, and they're still equal to each other as long as you flip both sides. So that means A over sine of big A equals B over sine of big B equals little c over sine of big C. And just depending on the situation you're in, you use whichever one is more convenient. And that's it. It's just a matter of, can we solve the triangles? There's a couple little caveats we have to figure out along the way. But this first one, I bet you might be able to do on your own. Solve the triangle. When you have 30 degrees here, 50 degrees there, and we know this side is 10. And something that's good for us to do, I'll kind of leave that there. Something that's good for us to do is label things. So let's call this big A, call this little a, call this big B, call this little b, little c, and big C. So hopefully we notice that right off the bat, something's really easy to find, and that's big C. So we can comfortably say that big C equals 180 degrees minus 50 degrees minus 30 degrees, which is a nice, neat 100 degrees. Nailed it. C equals 100 degrees. All I need now is little c and little a. And notice, which of these fractions do I start with? I have to start with the b's because I know both of those items. I can't start with the c's because I don't know both of them. Can't start with the a's because I don't know both of them. Start with the b's and go from there. So I'm going to say that little b, 10 over sine of 50 degrees equals, and you can choose any side. I'll start with a, little a over sine of 30 degrees. That's what we're going to have here. And just to be the most clear, right, this is little a, that's big A. Sorry, that's not correct. That is little b, that is big B, little a is right there, and then big A. So it matches the formula. And then it's just a little algebra problem. So I start to solve this algebra problem. I now see I have to multiply sine of 30 to both sides, and you get A equals 10 over sine of 50 degrees times sine of 30 degrees. And then it's just a matter of plugging that into your calculator. And something that's going to be a little bit weird compared to last chapter, we need to make sure we're in degree mode. So change your calculators to degree mode. And then what you're going to get is hopefully little a equals 6.53. And that'd be one unknown side. Cool. And sometimes it's nice to put these things up here. 6.53, big C is 100 degrees. And the reason I say that is it's a way of double checking your answer. The side across from the smallest angle is the smallest side. So the fact that 6.53 is less than 10 makes sense because 30 is less than 50. So in theory, this big C should spit out the biggest side so far. Let's test it. We have to run law of sines one more time. 10 over sine of 50 degrees equals C over sine of 100 degrees. It's the same exact formula. So at this point, it'd be a big help if I press, or if you pressed pause and then went ahead and tried to solve this. So now that you've definitely done that, press pause and solve this on your own. Just noting what everything is. This is a big C there. We can see that little c equals 10 over sine of 50 degrees, sine of 100 degrees, c, little c equals, doing the same thing here, and we should see about 12.86 as your final answer. 12.86. And now we've solved the triangle. We've solved the triangle. Sweet. So many of your problems will go as smooth as that. But this next situation is where we get into a little bit of a weird space. So here's a fact. For a triangle that we know is side-side angle, right? You know the side, the next to a side, and then you know the angle. There may be 0, 1, or 2 possible triangles. And I'll show us a picture here on the board so that makes a little bit of sense. All right, so let's look at this on the board. Hopefully we can see that decently well, that picture. So that's actually not that great, but yeah, let's see. Maybe I'll make the lines a little darker. So we know this side here. We know this angle. This side, I don't know how long it is. It could be any length. But what I do know is this other side that goes up here. But I don't know the angle. So this last side is on a hinge, really. So when my last side's really long, you can see it falls right around here. I make a triangle. You can see the triangle looks really nice. And that's the only way I can go. If I pivot up, it doesn't make a triangle. If I pivot here, it's perfect. If I pivot all the way over here, can't create another triangle. So that's the one triangle situation. But then there's this other situation where now I have this length. I've made a triangle, no problem. But if I pivot, I actually have this awkwardly shaped little mini triangle right here with the two sides. It's just short enough to where I create a triangle here and a triangle there. So I need to consider both triangles, right? That's the two answer option. And then there's always the option where the side is too short. So no matter how far I pivot, I'll never reach that bottom line because this angle is fixed. I can't change that angle. My angle up here can do whatever I want. So bottom line is there are sometimes 0, sometimes 1, sometimes 2 triangles. But the math always tells you the situation you're in. You don't have to draw a picture or anything like that. You'll see it in the math. So let's look at it. Example. Solve the triangle. You got this going on. And actually, let's say this a little bit better. Sorry, don't draw that picture. Let's say, solve the triangle. ABC, when big A is 35 degrees, little a is 6, and then little b is 8. So now we can draw our triangle if we want to. So I got, 35 degrees, something small like that. And we called this big A. And on the other side, I have a 6. And let's say this side is an 8. And on this side is about a 6. Little a, and call that little b. Now, I don't need to draw a picture. Hopefully you can see I see an A and an A. I know I can run law of sines here. So I do that. Law of sines says sine of 35 degrees over 6 equals sine of big B over 8. And I knew to put the signs on top because the angle was the unknown in this part, right? I knew the side, I didn't know the angle. So it's a little bit more helpful to put the unknown thing on top. So what I do here is I start to solve for B. Equals sine of B equals 8 times sine 35 degrees over 6. And this is now just like a problem from the test that we took from last chapter. So I have sine of B equals 8 times sine 35 divided by 6. 0.76. 0.76. And now I find B, right? I use sine inverse. B equals sine inverse of 0.76. And that gives us 49.46 degrees. But remember, just like we did when we're solving equations for trig equations, there are 2 answers in the unit circle. So I have B equals 49.46, or, right, if I were to draw the circle, the unit circle looks like this. 49.46 goes there. But I have to consider this other angle. And for that other angle, it's going to be 180 degrees minus 49.46 degrees. And we get 130 degrees. Is totally an option. Or B equals 130 degrees. 0.54. 130.54. All right. So we consider both options. We move forward saying B1 is 49.46 degrees, and B2 is 130.54 degrees. So in this situation, the next answer that's easy to find would be big C. So big C1 is going to equal 180 degrees because the triangle adds up to 180 minus 49.46 minus 35. To whereas C2 is 180 degrees minus 130.54 degrees minus 35. And you throw that in a calculator, right? No need to do either of these in your head. C1 over here is going to equal 95.54 degrees. And then on the other side, let's see. Big C2 is going to equal 14.46 degrees. So I'm starting to see answers, right? I have an answer here, answer there, answer here, and an answer there. But I'm still missing one piece of information for both triangles, little c. So to find little c, I do the same thing that I did in the last problem. I use law of sines. So I'm going to say 6 over sine of 35 degrees equals little c1 over sine of 95.54 degrees. Then I have c1 equals sine of 95.54 degrees times 6 over sine of 35 degrees. C1 is then going to equal, just plugging this into my calculator, 10.41 degrees. Okay, and I rinse and repeat for the next one. You can probably press pause and do this on your own, but I'll burn through this. Little c2, 6 divided by sine 35 degrees equals c2 over sine of 14.46 degrees. Move it over. C2 equals sine of 14.46 degrees, 6 over sine of 35 degrees. C2 then equals, just burning through the same thing, C2 equals 2.61. And I apologize, this should not have been a degrees on this left side. It should have just been a number, because it's a side, not an angle. Beautiful. So 2 triangles is always an option. So the moral of the story, whenever you're solving for an angle, always check the other answer, right? We know that the other answers exist, right? We spent a whole 3 weeks probably on that in the previous chapters. So that's where we are. So let's keep going. We got 2 more examples in this section, then we can move forward. Let me fix this the way it looks. Let's look at another example. So we're going to say, solve the triangle. We will say where little c equals 85 degrees, big C equals 12, and little b equals 9. And when you do this on your homework, there'll probably be units, inches, or centimeters, or feet, whichever. But I'm not ultra concerned about that. It's about getting used to using these trig functions. So you start moving. You attack this just like the last one. So it would be a good idea to press pause and try this. So now let's try this together. I don't even need to draw the triangle. I'm going to say sine of 85 degrees over 12 equals sine of big B over 9. Burn through the math. Sine of B equals sine of 85 degrees over 12 times 9. And then just plugging this in a calculator now, not doing anything special. Sine of big B equals 0.74 Oh, 0.75. When you're working on MyOpenMath, I recommend trying not to round, or if you need to round because your calculator is kind of not as helpful, especially those of you using iPhone calculators, make sure to round to at least 4 decimal places so we do it correctly. But anyways, sine of 0.75. Sine inverse, b equals sine inverse of 0.75. Big B is 48.59 degrees. We can call this B1. And then we have a B2 over here I need to consider, which is 180 degrees minus 48.59. And we get a 131.41 degrees. Now, hopefully we noticed, if you're doing this on your own, we run into an issue. Because now I'm going to start to look at big A2. Big A2 is going to equal 180 degrees minus 131.41 degrees minus 85 degrees. And then you suddenly look at that, that's too many degrees there. You subtract that off, and it's a negative number, negative 0.41. Basically, no second triangle exists. So this is the situation where I had the perfect length and it just hit on one side and didn't hit on the other side. So I just focus on this one. I have an answer there. I know big B is that. So now I can find big C. Nope, I already know big C. Big A1, 180 degrees, minus 48.59 degrees, minus 85 degrees. It's 46.41 degrees. A1 is 46.41. Box it. Then with that, I can use law of sines again to find the last piece of information, which would be little a. As I'm looking at this, I believe I've given us a little bit of odd information. This should be big C, and this should be little c. We probably didn't notice that as we're going through, but it'll be more clear on MyOpenMath. But anyways, so I find the last little a here. So I know that little a over sine of 46.41 degrees equals little c, which would be 12, over big C, which would be sine of 85 degrees. So I put this in. A equals 12 over sine of 85 degrees times sine of 46.41 degrees. A equals 8.72. 8.72. Those are your three answers. So I hope this is starting to make sense. We're going to try one more quick one with law of sines, and then we'll move forward to law of cosines. Again, I fix the view. Solve. the triangle ABC with little a equals 4, big A equals 50 degrees, and little b equals 10. So, I mean, it's getting redundant at this point, right? We go ahead, we start moving through this, and we see sine of 50 degrees over 4 equals sine of big B over 10. Then we have to be careful because we need to make sure to check for that second angle. We get sine of B equals, plug it in your calculator, and we get 1.92. And no problem, B equals sine inverse of 1.92. And hopefully you notice in your calculator, B does not exist. Error. It doesn't make sense. And that should be clear at this point, really, because remember this graph of sine, it bounces back and forth between -1 and 1. It never goes above 1. So it'll never hit 1.92. So your answer to this question would be no triangle exists. That's when we had the little short one, right? Right up here where we couldn't reach it. So, yeah, right up here. You can't actually see anymore. But basically, one side's too short, and I'm not hitting anything. I can't hit that bottom line. So that's that there. Sweet. Those are the situations for law of sines. So now we move forward into the law of cosines. I'd recommend taking a break before watching this part of the video, just because it's a long video. But let's move forward here. 10.2, law of cosines. Now, law of cosines, I would say, is a more complicated formula to use, but the situations are a little bit more straightforward. There's two situations. There's no 0, 1, or 2 options or anything like that. There's only one option for each of these situations. So here's a fact. Remember, these are for side angle side and side side side. For a given triangle, by that same setup, little c, big C, big A, little b, big B. The following are true. C squared equals A squared plus B squared. And you must be thinking, tight, I know that one. That's Pythagorean's theorem. But remember, these aren't right triangles. So we need an adjustment. Minus 2AB cosine of big C. So look, these are opposite of each other. Opposite and opposite. So I can rewrite the equation in any sort of way as long as that angle, that cosine angle at the end, are opposite that first squared side. So we get b squared equals a squared plus c squared minus 2ac cosine of big B. And these wouldn't really be formulas I expect you to memorize. So don't worry about that. It's not something that comes up later in a calc course that you must have memorized. So we should be safe. A squared then would also equal b squared plus c squared minus 2bc cosine of a. So let's see what's happening here. Let's look at the situation that you might find yourself in. Example. Solve the triangle. We'll draw this one out. A equals 10, little a equals 10, little c equals 12. This angle is going to be 30 degrees, which we'll call big B. So at this point, you can see, I mean, I can't even use law of sines if I want to, because I don't have any sort of oppositeness. I don't know little b and big B. I don't know little a and big A. And I don't know little c and big C. So kind of jammed here. Kind of jammed. It's not a problem. That's why law of cosines exists for the side angle side and the side 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 type triangles. So I start to work on it. What am I going to want to solve for? Well, the only angle I know is the cosine of B, which is 30 degrees. So I need to pick from those three, the one that uses big B as the value there. So it's got to be little b squared equals 10 squared plus 12 squared minus 2 times 10 times 12. Hopefully we can see that is little a. That is little c. Little a, little c. Just matching the formula there. And that's a big old ugly thing. You just need to enter in your calculator. So we need to be smooth at our calculator. So even for those of us using our phone calculators, if you have an iPhone, I highly recommend picking up a regular calculator. Androids or downloading a calculator app. It's just going to be better than your standard calculator. Androids generally are a little bit better calculator-wise. So I'm just plugging this into the calculator. Be careful here because it does take a little bit. And we get b squared equals 36.15. And then from there, we just square root both sides. Little b equals about 6.01. Yeah, 6.01. And I know you're supposed to have a plus or minus there, but we're talking sides, so that is little b. But of course, we're not actually done right because I still need big C and big A. But now I'm free to use law of sines. And law of sines is a little bit easier, so we just use that. Could I use law of cosines again? Of course. But there's no need to. So sine of b, 30 degrees, over 6.01 equals sine of big C over 12. Sine of big C equals 12 times sine of 30 degrees over 6.01. Plug that into a calculator. Yeah, and we get sine of C equals 0.998 about. So then C you come to find equals 0.998, sine inverse of 0.998 big C has got to be 86.38 degrees. (86.38 degrees). All right. Sorry about that. I had to press pause randomly for a second. I had to check something. But anyways, so you see C equals 86.38 degrees. Or, remember, we have to check both of them, 93.62 degrees. And there's not a good way to check which one is correct. But remember, I just told us that law of cosines is easier. There's not this two triangle business, and that's true. There isn't a two triangle scenario. So what we come to find out is this is correct. Because if we were to run law of sines on the other angle, so if I said sine of 30 over 6.01 equals sine of big A over 12, and just run the same thing, sine of A, sine of 30 over 6.01 times 12, you'd very quickly see, just running that calculation, 12 times sine of 30 divided by 6.01, and you get, oh, not 12. We just said not to do that. Opposite A is 10. 10. So we're going to, and then we get A equals 0.83. You get A equals 56 degrees. 56.23 degrees. So that only makes sense with this answer, right? Because of course I have the option of saying, or 180 minus this. But you can pretty quickly see that that doesn't work either. So the only way this works is with 56.23 and 93.62. But since we don't want to be running law of sines more than once in a problem, if I don't have to, here's the trick. So that's the answer, by the way. C equals that, A equals that, little b equals that. Here's a tip. Always solve for the smallest angle first. Then I won't run into that little scenario that I just did, and my life will just be a lot easier. So I know this has been a very long video. Let's try one last one. One last example, the last possible situation you can find yourself in. Then everything in these two homework assignments should be solvable. Solve a triangle, ABC, when little a is 5, little b is 7, and little c is 10. And draw your triangle. Maybe call this one little c, 10, b, 7, little a, 5. And now remember the tip I gave us. Always solve for the smallest angle first. So which one would that be? Big C, big B, or big A? Well, it's going to be the one opposite the smallest angle, or the smallest side, which would be big A. So I know I want a cosine of A in the problem, which means I should see an A squared first. 5 squared equals the other two sides squared minus 2 times the other two sides, 7 and 10, times cosine of A. So I start to plug this in a little bit carefully now, because that cosine of A really messes some things up. So I do this in a couple steps, and I guess just to be clear, this is little a, little b, little c, little b, and little c. But I plug this in very carefully. I say 25 equals 149. I added those two together to get that, minus 140 times cosine of A. And then this is just like a problem from last section. Subtract that over. 25 minus 149. And I know it's a negative number, but that's okay right now. Equals negative 140 times cosine of A. Cosine of big A is then going to be those two numbers divided by each other. 0.89 is what cosine of A equals. So now A is going to equal cosine inverse. Which is 27.13 degrees. And I don't need to worry about the other angle for cosine because it would be over 180 degrees and it's fine, right? Cosine's more straightforward. It's a harder formula to use, but it is more straightforward. So now I have little a. I'm sorry, big A. That's a big A. So now that I have big A, I need another angle I want to solve for. So I can comfortably say, sine of 27.13 degrees over little a. Now I can put this, 27.13 degrees. 5 equals, what's the next side I should solve for? Hopefully we're all screaming B, because it's the next smallest angle. 7 under sine of B. I run it. Sine of big B equals 7 times sine of 27.13 degrees over 5. And I run that. Times sine of 27.13. And hopefully you can probably start to do this without me at this point. Equals 0.64. B now equals 0.79 degrees. And then last but not least, we need to figure out our last angle, 180 degrees minus 27.13 degrees minus 39.79 degrees, which equals 113.08 degrees. And that's. So law of sines, law of cosines, right? It takes some work, it takes some practice, but a very manageable section, in my opinion. What I will say though, with MyOpenMath, be careful with your decimals. Try to round as little as possible. And if you're rounding in the middle of a problem, round to at least 4 decimals. I know I was using 2, but that was just to help with the lesson. For my open math, please make sure to round to at least 4 or don't round at all. But without further ado, good luck this week, and I will hopefully see you in the next office hours or in next week's video.